Happy Monday, Algebra students. We are finishing up 11.7. You worked on adding and subtracting radicals on Friday, which was day 1, and today we're jumping into multiplying. And then actually starting the rest of the week, Tuesday on, and a little bit into next week, we're going to talk about using radicals like within equations. We'll just be solving equations, there just might happen to be a radical. So we've been doing a ton of work with radicals, and it's really just leading us on to this week, which will be, can you solve equations with a radical in it, which I'm hoping you guys will feel comfortable by tomorrow. Our essential question is simple. Can I multiply radicals? There is one huge thing you need to know right away, is that unlike adding radicals, you do not need like terms. And I'm going to show you what that means right now with an example, but I do want to clarify that those like terms were a square root of 2, and a square root of 2 was 2 roots of 2, right? You were able to add those up. Or 3 roots of 3 plus a root of 3 is 4 roots of 3. You don't have to write those down, but those are what like terms are, where we were combining them. But you will see with our example right here, the square root of 8 times the square root of 2. A square root of 8 times the square root of 2, I would hope that even on Monday, or I'm sorry, it's Monday, Friday, you would say, hey, there's something not right here when I am looking at an 8 and a 2. They're not like terms, but unlike adding, you do not need like terms. So in this case, there's a little multiplication symbol there. 8 and 2, you can just take those radicands, or those numbers underneath the radical, and multiply them like that. So 8 times 2 is 16. That is a shift I'm hoping you feel comfortable making. Now, at that point, I would say, okay, simplify it. This is the new part. The rest of the problem will just be previous knowledge. Can you simplify this radical? Now, in this case, you can. It ended up being a really nice number. So that's why we're simplifying. You don't write this down if the answer's 4. We want to always take this and make it as simplest as possible. So let's look at another example. Number 2, the square root of 6 times the square root of 3. So, similar here, we're just going to take the radicands, multiply them. That is the square root of 18. That right there is your new part. That is today's new information. And the rest of this is saying, okay, well, now that I have the square root of 18, what do I do? Can I simplify that? And we can, because there is a perfect square that goes into 18. So my perfect squares are 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8. We don't need more today, but you have those available to you. Is there a perfect square besides 1 that goes in 18? Because if there isn't, we're done. But there is. 9 does. Ooh, I got a little crazy there. 9 does. So this is the square root of 9 times the square root of 2, because those multiply, right? 9 times 2 is 18. So we're just choosing 2 different numbers that multiply to be 18, but one of them is a perfect square because the square root of 9 is 3. So that's 3 roots of 2. So we take something that looks, and you might be arguing to yourself, oh, wait, is this really more simpler? Like, what's going on here? You never want 2 radicals if you can avoid it. So putting it into one and then simplifying it is how you would appropriately simplify it. Let's try something. Again, no new concepts besides the multiplying piece. This one just might look a little bit different. So let's try a different one. The square root of 14 times 2 times the square root of 2. So it's the square root of 14 times 2 times the square root of 2. Now, 2 square roots of 2 is just 2 times the square root of 2, right? And so we can multiply those in a whole bunch of different orders, because we can multiply in any order. And I'm going to skip ahead, and I'm going to multiply 14 and 2. I'm going to combine them times 2. Don't forget about him. He just comes right down. He doesn't move. So this piece, these arrows right here, bringing everything down, is just that first step of multiplying the radicands. So I've multiplied 14 and 2, got 28. At this point, you've done the new stuff. You are now just simplifying. So, is there a perfect square that goes into 28? Yes, there is. What is the perfect square? It is 4. 4 goes into 28 7 times. So let's look and see if we can simplify this. This 2, don't forget about the 2. 2 just gets spread over. But the square root of 28 is 4 and 7. And why do we like square roots of perfect squares? Because they turn into whole numbers. Oh no, I kind of ran out of room. That's okay, I'll make it work. So 2 times the square root of 4, which is 2 times 2. Square root of 7. And what is 2 times 2? What can I can multiply those coefficients together, which is 4 roots of 7. And that's your simplified answer there. So not very simplified, 2 radicals, things were in the wrong order. Here we have 1 radical, nothing, I can't simplify the radical, there's 1 coefficient. We're good to go. Let's try one more. 3 times the square root of 7 times the square root of 2. Okay, so 3 roots of 7 times square root of 2. I put a little multiplication symbol in there, just like I put a multiplication symbol in there, where it's just 3 times the square root of 7, 3 roots of 7. Find everything, all the radicands can be multiplied, so I'm going to bring those down here. That turns into the square root of 14. Don't forget that little 3. He gets brought down, don't forget him. Okay, what perfect square goes into 14? Does 1? Well, yeah, but that's not going to help us, because I could take out a 1 and a 14. 4 doesn't go in, 9 doesn't go in. No perfect squares go in. My radical is simplified. I'm done. So sometimes a problem might be a lot of work, and sometimes a problem might not be a lot of work. But your main takeaway from today is multiply those radicands, and at that point, the rest is something you should already know how to do because all you are doing is simplifying those radicals.